Hello, this is Malachi, and this is my Doodlecast electricity presentation.
So are you going to use it?
An electric current is when in a circuit when negatives move from positives and positives move from negatives. How electric current is different from static electricity is that static electricity is a buildup of electric charge, and an electric current is when negatives move to positives. The three particles that are found in atoms are protons, which are positive, neutrons, which is neither positive or negative, teeny tiny neutrons, and electrons, which are negative. Negative. The protons and neutrons are found in the middle of an atom, and the electrons are found on the outside and are really small. The protons and neutrons are really big.
Is enough of a flow.
The particle that moves in an atom is the electrons, because they are really small and lightweight. This happens because, and the other charges, which are neutrons and protons, are really big, so they cannot move. I mean, protons and neutrons are big and they're unable to move. Which direction does the particle move in a circuit? Positive to negative or negative to positive? Well, since electrons are negative, they're going to move to the positive. Because they are not positive. If electrons were positives, and then they would move to the negative. But that doesn't exist because electrons are not positive. So dumb. Why do the particles move in this direction and not the other way? Because when electrons are negative, they're going to go to the positive. And once they're in the positive, they're going to go to the negative. In a circuit, this is actually what happens. It goes from negative to positive to negative to positive. And maybe hit that awesome light bulb. Maybe. No. Erase. Do opposite charges attract or repel? So, opposite charges attract each other because negative attracts to positive. That means electrons are going to go to the positive when they're the negative. But if they were the same charges, they would repel each other. Voltage is the difference in charge across a circuit. That's all I'm saying. Because the reason why you need a battery in a circuit, because the battery has electrons probably on the negative side. And they're going to go through a wire and hit a light bulb. But if the electrons don't have a source, then that light bulb is not coming on. Luckily, the battery will always be there to help them. You must always have a battery to complete a circuit. How does a battery create voltage in a circuit? Well, basically where a battery is where the electrons are. So it's their source. So when they go through the light bulb, if the wire isn't there on the other side, then the light bulb will turn off. But when it's there, the light bulb will turn on. What are resistors? Resistors are, in a circuit, technically a resistor is the light bulb because the electrons have to flow through it, but when they come back out on the other side, they'll feel less weak. So I will show you an example right here. This is what happens in a wire. The electrons, maybe a lot of them, are going through the wire all happily, dappily, maybe, to light up the light bulb. And then once they turn the light bulb on, and they come back out, they're not that active. There's not a lot of them. How can we use resistors in a circuit to create heat or light? Well, when the battery has many volts, there are many more electrons. And when they come back out, there'll still be like a lot more. Because depending on how many electrons are coming from the battery is how bright the light bulb is going to be. So this is the Ohm's law. More voltage equals more current in a circuit, but more resistance equals less current. How would you increase the strength of a current flowing through a circuit? Well, guess what it depends on? The battery, aka volts. Depending on the battery, if it has like 1.5 volts in it, which just means it's not a lot of electrons going through it, and compare that to a big battery, which has way more volts, like 6 volts in it. So if you use the 6-volt battery, usually there'll be more electrons going through the wires and the light bulb will go off really lightly. But if you use this one, it may not be that bright. You can still see it. How would you decrease the strength? Use this light bulb. Not this one. This increases. This is how you decrease the strength. So, when you use a small battery, this is how you decrease the strength. The light bulb will not be that bright. It will be like that much bright. It's so dim that you may not be able to see it. What is the difference between series and parallel? Well, I will show you series first. This is a series. Just a regular light bulb. And if you want to add another light bulb, you can. If I can draw it. I'll show you a parallel. So, basically, series is just a regular circuit, have a battery, have two wires connected to a light bulb, and the light bulb goes on dimly. But when you have two series, I meant parallel, this is what it looks like. So here's how kind of parallel works. If you take out this light bulb will stay on. In a series, if you take out one of the light bulbs, both of them go off. Pretty cool. How this works is that when the light bulb turns off, usually the electrons go through a whole circuit. When the light bulb's turned off, it has a choice. It can go either here or down here, or it can go up here. The tricky electrons. And the light will still be on. So when the light's off, let's say this whole wire thing right here is off. That's where this wire is connected to that right there. And that's where the top wire is connected to here to go to the battery. And if the light bulb's off when we take off the wires, that light bulb will still be on and still be at the same brightness. And this is how basically our houses work. If you have multiple light bulbs in one series, for a series, the light bulbs kind of share the awesome energy. So, this is a series. Regular light bulb chilling. Had the brightness all up in his joint. So, this is a bright light bulb. But when it adds in a series, if you add another light bulb, one of them, they share the energy. And one gets dimmer. See how they shared it? Because I have to. But in parallel, like I showed before, I'll draw it again. The tricky problems. If one of the light bulbs go off, the electrons don't have to go through that circuit, and they can go through the upper circuit. So let's say they're at the same brightness, around the same brightness. If one light bulb gets unscrewed or turned off or whatever, that light bulb still stays on at the same brightness. And that ends my doodlecast. The end.